Identify the number of valence electrons and draw the Lewis dot structure. Remember that metals tend to lose their electrons, falling back to their inner orbital, forming positive cations. Nonmetals tend to gain electrons, filling up their current orbital, forming negative anions. So if you go think back to the gizmo where you had that sodium atom and the chlorine atom, which we see here. The sodium is a metal, and we know this because if we look at our periodic table, here's sodium in A, and it's to the left of this staircase. So everything to the left over here is metal. Sodium ends up giving up its electron to chlorine, right? So metals tend to give away their electrons, which is what this says. Metals tend to lose their electrons. Non-metals tend to gain electrons. So this chlorine, which is a non-metal, we know that because here's chlorine over here on the right side of the staircase. So our non-metals are over here. Chlorine gained an electron. So we're going to keep that in mind. And it's all about the octet rule, which you learned in the gizmo, right? Trying to get to 8 valence electrons. Okay, so let's keep that in mind, and let's fill out some of this chart. So our first element, sodium, the first thing we're going to do is the number of valence electrons. We need a number between 1 and 8. How many valence electrons are there? There's a few ways we can do this. If you want to look at your gizmo here, let's reset it. Sodium here has 1 valence electron, and we know that because it's on the outside orbital, and there's that 1 valence electron right there on the outside orbital. So we can see it that way from a drawing of an atom, or the really easy way is to look at our periodic table. I'm going to zoom in a little bit here. There we go. So here's sodium. Zoom in just a little bit more. The periodic can tell me how many valence electrons there are by looking at this number at the very top, right here, this number 1. That's telling me I have 1 valence electron. Okay? So these numbers on top tell us our number of valence electrons. It doesn't work for any of these in the middle. Okay, so all of these transition metals here in the middle, they don't follow our rules. Okay, so we have 1 valence electron for this first column, 2 valence electrons for this second column. We're going to skip everything in the middle here. Skip, 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 until we get over here. This says 13, but we can't have more than 8. 8's our magic number. So instead of 13, it's really 3. So this is all 3 valence electrons. This is all 4 valence electrons. 5, 6, 7. And here's our magic number, 8 valence electrons, except for helium, which is 2. There you go. So there's our easy rule for valence electrons. So if we look at this, sodium should have 1 valence electron. Let's go ahead and fill it in. You can fill it in on this by clicking text box over here, and then just clicking in the middle. And there you go. Type in 1. Now we want the neutral Lewis dot structure. Again, we're going to need to I'm going to write the element out. So use this text box again. And let's write out our element here. And we're going to get dots, which are our valence electrons here. We're just going to add 1 dot. I don't like how that dot looks, so let's do a little better. I'm going to click this undo button right up here to get rid of that. And I'm going to, hold on. Do we have anything better? Will this work? Oh, okay, now we're getting better. So undo. Alright, so to make these dots, let's make this a size 4 and just click once. There we go, 1 dot. 1 dot because we have 1 valence electron. Okay. Now it's asking, are we going to gain or lose electrons? Sodium is a metal, so we should lose 1. In this last column, what is our ion charge? Our ion charge should be, well, if we lose 1 electron, electrons are negative, right? So if we lose a negative, what is our charge? Our charge should be positive. So I'm going to say positive, and we just lost 1 electron, so positive 1. Here we go. All right, I hope it makes sense how I did all this. We're gonna do, let's do 2 other examples here real quick. I think that's okay. I'm gonna come down here, I'm gonna do S for sulfur. S. So first I need the number of valence electrons. So I need to find it on our periodic table here. And S is right over here. So, before I tell you, how many valence electrons do you think sulfur has? If you looked up here and you saw 6, you're right. So sulfur has 6 valence electrons. So text box, 6. For our Lewis dot, we need to put that capital S right in the middle there. I'm going to grab my dots. Still set at 4, so that's good. And I need 6 dots on here. So follow our rules. We'll go around all 4 sides. 1, 2, 3, 4. Now I have 2 more dots to put on. Now I can start pairing them up. 3, 4. I'm sorry, 5, 6. So here I have all 6 dots on sulfur. So this is what our Lewis dot structure looks like. Now then, are we going to gain or lose electrons? So what do you think? Does sulfur want to gain electrons or lose electrons? Sulfur should want to gain electrons. I know this because sulfur is a nonmetal. And as we saw up here, nonmetals tend to gain electrons. Great. So, nonmetals tend to gain electrons. Alright, sorry, I just wanted to zoom in a little bit here. So, we said it wanted to gain electrons because it's a nonmetal. And nonmetals want to gain electrons. So, I need to fill in my answer here by clicking on text box. There we go. Click on text box. And we're going to gain. How many electrons is it going to gain? Sulfur should want to gain 2 electrons because it wants to get up to 8. Right? 8 is our magic number. So sulfur gains 2 electrons. It'll go from 6 to 8 valence electrons. And finally, our charge. If it gains 2 electrons, what would its charge be? Each electron is negative. So if it's getting 2 negative charges, the charge should be -2. Alright, so I hope you kind of see the pattern here. If we lose electrons, our charge becomes positive. And we lose them because we have metals. Another way to think of it is we're trying to get to that magic number of 8. Okay? In a weird way, getting our valence electrons down to 0 is kind of the same as getting them up to 8. Okay? Because that's where our orbital is full. Okay? So if we get them all down to 0, like in sodium here, right? I made this orbital have 0 valence electrons on it. Now we're really just on this inner ring here, which is at 8. So we've gotten to that magic 8 number. In this case for sodium, it was much easier to lose 1 than it would be to gain 7, don't you think? So that's a common reason why metals tend to lose electrons, is they have fewer valence electrons. So if you lose an electron, it becomes positive, and if you gain electrons, you become negative. All right, pretty straightforward. I'm gonna let you guys actually do the rest. I know I said I'd do 3, but I'm gonna let you guys do the rest of these here. Please ask me questions if any of this doesn't make sense, or even if you want me to check your work, I'll be happy to do that. Come see me on Zoom or send me a message, and I'd be more than happy to check your work. Also, if you're having problems using any of this stuff on Cami, please let me know. This is all new, so I'm here to figure it out with you. All right, guys, work hard.